Let's discuss projectile motion. We will focus once again with the horizontal projectile. Okay, let's have this example. A cannon is fired horizontally from the top of a 30-meter cliff into the ocean. The initial velocity of the cannon was 1000 meters per second. How far from the cliff does the cannonball hit the water? Okay, first and foremost, if you have noticed in this problem, there's only one question and there is no given angle. For that reason, we can think that the 1000 meter per second is the final horizontal velocity for this problem. Now let's focus with the question. The question for this problem is that how far from the cliff does the cannonball hit the water? So in this question, it's obviously we are asking about the range of the projectile. Now to answer this problem, let's visualize this problem first. So there's a cannon and the cannonball was fired and hit the water. So the question is, how far from the cliff does the cannonball hit the water? So let's visualize other things in this image. So that is the angle, although it's not given in the problem, and that is the range. Now we are looking for the range, and let's see what are the given in the problem. We have the initial velocity of 1000 meter per seconds. The angle is not given, while the height of the cliff is given, which is 30 meters. Okay, we know that in calculating the range of the horizontal projectile is range is equals to V of x multiplied by time. But since we cannot get the V of x because there is no angle here, we can conclude that the VO, which is 1000 meter per second, is the final horizontal component of this problem. Even so, we are still missing one variable of that formula for range, and that is time. Now, in order for us to get the time for this problem, we should get first the final vertical velocity, and we're going to use this formula. The final vertical velocity is equals to the initial velocity squared plus 2ay and the change in vertical displacement. Now, always remember that the acceleration for vertical is always the gravity. Now, the change in vertical displacement is the height. Then let me copy everything in this formula. Now remember, when it comes to horizontal projectile, the initial velocity for vertical direction is always equals to 0. Then bring down the 2gh and we still have that vy squared at the beginning or the final velocity for vertical direction. Now to write this, we will have by squared is equals to 2gh. So now we have the final formula for the final vertical velocity. And then substitute the value. We have 2 then multiplied by the gravity, which is 9.8, and the height, which is 30 meters. Then we will end up having 588 meters squared second squared. Then get the square root of it. In this case, the answer is 24.25 meter per seconds. Since we now have the value of the final vertical component, we can now compute for the time by using this formula. The value of the final vertical component is equals to VOY plus GT. Then substitute the value. Vy is 24.25 is equals to, as we all know, VOY in horizontal projectile is equals to 0. Then plus GT, which is gravity and the time. Wherein the gravity is 9.8 meter per second squared multiplied by time. Now we do have this arrangement. What we can do right now is to remove the 0 first. And then we have this. What we can do right now is to divide both sides by 9.8 meter per second squared so that we can cancel out 9.8 alongside of time since we are looking for time. So now we can cancel it out. Therefore, we will have this. Don't forget to cancel out units. Then do the math. Then we have the value for time, which is 2.47 seconds. Now, since we have all the value to get the range, we can now compute the range of this projectile by using this formula, which is range is equals to final horizontal value, which is 1000 meter per seconds in this problem, multiplied by the time, which is 2.47 seconds. We will have a final answer of 2470 meters. Let's have another sample problem for horizontal projectile. The problem would be a stone fell from the cliff at a rate of 30 meters per second with an angle of 25 degrees. The questions are, First, calculate the horizontal velocity of the projectile. Second is how long the stone is in the air. And the last question is calculate the horizontal displacement of the projectile. Now let's try to visualize the problem first. So there's a cliff and there's a stone that fell from the cliff, which has an initial velocity of 30 meters per second and an angle of 25 degrees. Okay, let's answer letter A. The given are initial velocity and the angle. The formula would be Vox is equals to Vo cosine theta. And the solution would be like this. Would be 30. The horizontal initial velocity is equals to 30 meters per second multiplied by cosine 25. You will end up having 27.19. Now we have answer with letter A. We can include now in our given the gravity, which is 9.8 meters per second squared, and the height before we proceed with the letter B because we need them for letter B. Now the question for letter B is how long the stone is in the air if the height of the cliff is 25 meters. So we need to include the value of gravity here and the height. Now for letter B, it's a two-way process in order for us to get the time. So first we have the part one of letter B. The given for the part one of letter B or the gravity and height. That's all we need for the part one of this letter B. We need the gravity and the height of the clip. The formula that we are going to use is the Vy squared is equals to 2g. Now the solution will goes like this. We have Vy squared is equals to 2 multiplied by 9.8 meters per second squared multiplied by the height, which is 25 meters. Then don't forget to add the exponent of meters. So we have meters squared per second squared, and then get the square root of them. We will have a final answer of 22.14. Now, since we have the value of the final vertical component, we can now compute for the time, which is the part 2 of letter B. The given or the final vertical component, which is 22.14, and the gravity, which is 9.8 meters per second squared. And the formula that we are going to use would be time is equals to the final vertical component over the gravity. Now it's time to do the math. We just need to substitute all the value of these variables. Time is equals to 22.14, which is the final vertical component, and the value of gravity is 9.8 meters per second squared. Then cancel out units, then we will have the answer, which is 2.26 seconds. Now, since we have the time, we can now proceed with the letter C, which asking us about the range. So the given here are the Vox and the time. Then the formula that we are going to use, of course, would be the formula for range, which is range is equals to Vox multiplied by the time. Just substitute the value and now we can compute. And don't forget to cancel out units. Then the range for this problem is 61.45 meters. Let's now have a recap of this problem, wherein the projectile initial velocity is 30 meters per second, while the angle is 25 degrees. The height of the cliff is 25 meters, and the range of the projectile have traveled with that velocity and within 2.26 seconds is 61.45 meters.